Chapter first, electrical charge and field. We know what is charge. Charge is a one kind of quantity which we study in 12th science, and its unit is coulomb. Now we understand what is the basic properties of electric charge. First basic property of electric charge is additivity of charge. Additivity of charge means charge can be addible because charge is a scalar quantity. Charge is a scalar quantity, just like a mass which we study in 11th science. Suppose this is my hand. I put one box on my hand. Its mass is suppose 2 gram. And I put second box on my hand and its mass is 3 gram. So total number of mass is, yes, you can say m1 plus m2, means mass is directly addible. Just like charge is a scalar quantity, it's addible. For an example, suppose this is the box where 3 charges present, Q1, Q2 and Q3. Each one have a different charge value. Q1 is equals to 2 microcoulomb, Q2 is equals to minus 3 microcoulomb and Q3 is equals to 4 microcoulomb. Charge can be positive, can be negative. Okay, so that's why if we can say the total charge is denoted by Q is equals to 2 minus 3 plus 4. So the total number of charge in this box is nothing but 3 microcoulomb. 3 microcoulomb. Total charge of the system. Suppose the n charge is contains in any system, then total charge Q net is equals to Q1 plus Q2 plus Q3 plus Qn. So this is the additivity of charge. A simple basic property of electric charge, just like a mass. Basic property of electric charge is conservation of electric charge. Conservation. We all know momentum conservation, energy conservation. What is energy conservation law? Energy neither be created nor be destroyed, only transfer one form to another form. Just like electrical charge is a quantity which no new charges are either created or destroyed. Means in any isolated system, the total electric charge is always conserved. Total electric charge is always conserved. For an example, suppose this is one isolated box where 3 spheres is present. Each one sphere has a different charge, 2 coulomb charge, 5 coulomb charge and minus 3 coulomb charge. So we can say the total of charge in this box present is 4 coulomb. Yes. Suppose I set this box and each sphere gets different charge. Suppose that is first one get 4 charge, second one get minus 2 charge, then what is the amount of this third sphere? See, law is what? Always in any isolated system, charge should be conserved. So total number of charge should be 4 coulomb. See, so 4 minus 2, 4 minus 2, 4 minus 2 plus, suppose this is Q is equals to 4, because total is 4, so here is also total charge is 4, it should be constant. So 4 minus 2, 2, yes, so 2 plus Q is equals to 4, so Q is equals to 4 minus 2, it means 2. So the third sphere should be have number of 2 coulomb charge. 2 coulomb charge should be present in third sphere. So this is the conservation of electrical charge. Okay. In another sentence we can say charge gained by the one body, another body lose same charges. See, if I rub the glass paper or glass rod with a silk material, okay, if we take one silk cloth and I rub the glass, so what happened? After some time, glass and silk, in the glass the positive charge is comes, or we can say glass gets a positive charge and silk gets the negative charge. How this happen? Because the charge is transferred, electron is transferred. But suppose if we find that the silk cloth gets minus 2 coulomb charge, then glass rod should be plus 2 coulomb charge. Means what? The charge gained by the silk is equal to charge donated by the rod. Because if you donate the charge, you become positive. If cloth gets the charge, then there is negative. So this is the conservation of electric charge. Very simple. Quantization of charge. See, this is the third property of electric charge, quantization of charge. Its sentence is all free charge are integral multiples of basic unit charge, which is denoted by small e. See, we know proton and electron both have equal charge. 1.6 10 to the power minus 19. Yes, both have an equal charge, but sign is opposite. Sentence is all free charge are integral multiple of basic unit charge. Its equation is Q is equals to NE. Means if you take any charge present in any system or any free charge is present, that should be the integral multiple of basic unit charge. So Q is equals to NE. This is used for the all type of charges and is firstly denoted by or suggested by Sir Faraday. Okay. Suppose I take one example. How many electrons are present in minus 1 coulomb charge? In any system, minus 1 coulomb charge is present. So you can count how many electrons are actually present. One question. How many electrons are present in minus 1 coulomb charge? So 1 coulomb charge is given in a system. Find what is the amount of electron. What is the total number of electron? See, we can use this equation. Q is equals to Ne. Because quantization of electric charge. Q is equals to Ne. Make a subject to N. N is equals to Q by E. Minus 1. It means, yes, negative charge. Negative charge means electron is present. We use only 1 because number is always, yes, number is always positive, not negative. Always positive. So 1 divided by 1.6 10 to the power minus 19 is the value of E. Okay. So that is the total number of electron present in minus 1 coulomb charge is 6.25 10 to the power 18. This much electron is present in 1 coulomb charge. Okay. We study the basic property of electric charge. Based on that, our second example of NCERT textbook is if the 10 raised to 9 electron moves out of body to another body every second, means in 1 second 10 raised to 9 electron is transferred to second body. How much time is required to get 1 coulomb charge on another body? Suppose this is first body A, this is second body B. In every second, suppose this is connected to some conducting material. In every second, 10 raised to 9 electron transfer from A to B. So, our requirement is 2 coulomb charge. So, for the 2 coulomb charge, how many time is required? See, as given in question, in every second 10 raised to 9 electron, and we know each electron have charge 1.6 10 to the power minus 19. Yes, 1.6 10 to the power minus 19 coulomb charge every electron have. So in 1 second, how much charge is transferred? In 1 second, 1.6 10 to the power minus 19 into 10 to the 9. 10 to the power 9 electron is transferred. So we can say 1.6 into 10 raised to minus 19 into 10 raised to 9. How this come? This comes from our equation quantization of charge. Q is equals to Ne. So number of electron is 10 raised to 9 and charge of unit, that is 1.6 10 raised to minus 19. So this charge transfer in 1 second. So for this transfer from A to B, required second is 1 second. How much charge we require? 1 coulomb charge. So this much coulomb charge takes 1 second. Then for the 1 coulomb charge, required time is what? See, the cross multiply. So time required is T. T is equals to 1 cross 1 1 divided by 1.6 10 to the power minus 19 into 10 to the power plus 9. So it will become 1 upon 1.6 10 to the power minus 10. And when we divide this, then time is t is equals to 6.25 10 to the power, this become positive. Okay, so that is 9 seconds. See, 10 to the power 9 second, it's big time. If I convert in a big unit, then it's near about 198 years. It's near about 198 years. See, 1 coulomb charge is such a big unit. Okay, so normally in a day-to-day life we use microcoulomb charge, nanocoulomb charge or millicoulomb charge. So we use the minimum or the micro amount or the micro unit of charge. Okay, because for the 1 coulomb charge we takes 198 years. This is such a big time. Okay. Our third example, NCERT's third example is how much positive and negative charge is there in a cup of water. This is the example on the basis of basic property of electric charge. See, in 1 cup of water, 250 gram water is available. Either 250 gram or 2 ml because density of the water is 1. So we can write 250 ml or 250 gram. See, in water solution equation is H2O, hydrogen and oxygen present in a water. Find positive and negative charge. See, proton has positive charge, electron has negative charge. In every molecule, proton and electron is present. So if we find the amount of or the number of proton available in water and number of electron available in water, then we can say this is the amount of charge. Okay, so first of all we find what is the total number of electron or proton present in a water. How we can find this? See, in H2O molecule, so in one molecule we can say 2 hydrogen is present in each hydrogen because hydrogen number is 1. So 1 proton and 1 electron is present. So in 2 hydrogen, 2 proton and 2 electron are present. H2O, yes or no? For oxygen molecule number is 8. So oxygen molecule number is 8. Here only 1 oxygen molecule is present. So 8 proton and 8 electron. So we can say the total number of proton and electron present in one H2O molecule is 10 electron and 10 proton. So if we find how many molecules are present in a 1 cup of water, then we can say what is the total amount of electron or proton. Yes, see, we knew that. In 18 gram is mole of 1 mole of water. So in 18 gram means in 1 mole 6.022 10 to the power 23 molecules are present. Yes, we know. We have 250 gram. So in 250 gram, how many molecules are present? Yes. So 250 multiply 6.022 10 to the power 23 divided by 18. This much molecule are present in a water, and each molecule contains 10 electron and 10 proton. Each molecule contains 10 proton and 10 electron. Either you say 10 positive charge and 10 negative charge. So total number of electron is 10 multiply 250 into 6.022 10 raised to 23 divided by 18. This is the net or total number of electron or proton. Now we use the equation of quantization. Q is equals to Ne. Q is equals to Ne. See, by this equation we can find the total charge present in a water. Q is equals to Ne. E is what? 1.6 10 to the power minus 19 electron charge. Total number of electron is this much. So simply multiply the 1 unit charge. So here we can say that is Q is equals to 10 into Q is equals to 10 into 250 into 6.022 10 to the power 23 into electron. Electron charge is E is equals to 1.6 10 to the power minus 19. Yes, 19 coulomb charge. So 1.6 10 to the power minus 19 and see here divide by 80. So this is divided by 80. When I solve this equation, then it's get Q is equals to 1.338 10 to the power. See, 10 is what? 1 molecules have positive and negative charge. 250 is gram of total water. 18 is a molecule. 1 mole gram. 1.6 10 to the power minus 19 is E, and this is the Avogadro number. When we divide this or solve these things, then Q is equals to 1.338 10. Q is equals to 1.338 10 to the power 7 coulomb charge. 7 coulomb charge. See, this is the charge present in a 1 cup of water. Here we can say positive and negative both charges equal because the 10 proton and 10 electron present in a 1 molecule. So we get the charge is same for the positive and negative. So by the electrically the water is neutral. So if you drink a water, you never get a shock. Why? Because it's electrically neutral. In this example, we see that in a 1 cup of water, this much of charge is present, positive and negative both. So by your own, you can find in 1 bucket of water how many positive and negative charge is present. Take in 1 bucket of water is suppose 20 liter. Okay, and solve it by your own. Thank you. The next example on a basis of property of electric charge is exercise number 1.11. A polythene pipe rubbed with the hole is found to have a negative charge. This Q 3 into 10 raised to minus 7. Q is equals to 3 into 10 to the power minus 7. This is negative charge. See what happened? If wool rubbed with the polythene, then wool gets positive charge and polythene gets negative charge. It means what? Electron is transferred from wool to polythene because acceptor become negative and donor become positive. Yes. So see, our question is estimate the number of electron transfer. Here we clearly see that polythene gets negative charge, so electron is transferred from wool to polythene. So number of electron is our question. See, for the quantization of charge, Q is equals to Ne we can write. Yes, so Q is equals to Ne is equals to minus 3 10 to the power minus 7. Electron is transferred. So here the charge is negative. Number of electron we can find by this equation. Electron charge is minus 1.6 10 to the power minus 19. This is the total number of charge 7 10 to the power 12. This much number of electron is transferred from wool to polythene. So see, question is electron is transferred. How many number of electron is transferred? From which? Which means wool to polythene. Yes, because wool get positive charge and polythene get negative charge. So of course wool to polythene. This much number of electron is transferred. Second question is there a transformation of mass? Yes, of course, because electron is not only have a charge, electron also have some amount of mass. Electron is also some amount of mass. that is Me is equals to 9.11 10 to the power minus 31 kg. Means if electron is transferred, then charge and mass also transfer. So here electron is transferred from hole to polythene, and this much amount of total electron is transferred from hole to polythene. So the net amount of mass transfer from hole to polythene we find by this number of electron. So this much number of electron, this is the 1 electron mass. So simply multiply these two things and we get the 1.9.11 10 to the power minus 31 multiplied to 1.87 10 to the power 12. By this multiplication we can find the total mass transfer from wool to polythene, and that is 1.7 10 to the power minus 18 kgs. Yes, it's very small amount of mass, but some amount of mass is transferred from wool to polythene. So after this example we can say, or the question we can say, when a body gets charged, if that gets negative charge, then not only its amount of electron is changed, but its mass is also changed. It gets some amount of electron and its mass is changed. And when some body is donate the electron, so it get positive charge, but its mass is reduced. Yes. So this is the one example of our exercise in CRT.